Good morning, students. This is Mr. Patinsky, and we are in 3.1 on page 62 of our Big Ideas Math Student Journal. So um, we're just going to do a quick rehash of what our core concepts are for this chapter, and that is our vertical line test. So this can be done in many forms. So just the big understanding is a graph represents a function when no vertical line passes through more than one point on the graph. So a graph represents a function. So that word function, that is the key part of this. Okay, so if you wanted to go in and highlight that, all right, function. So we always want to say is something a function or not. So this is determining if something is a function through the vertical line test. Okay, and we can see that. So if our line went through more than one point, it would not be a function. But if it only goes through one at any point on the graph, we could make it go through 2 points. When we draw that vertical line, then it's not a function. So function, not a function. Right. The other thing, somewhat of a review, is domain and range. So domain is going to be all the possible inputs. Okay, so those are your x values. All right, so if you wanted to make a note off to the right, x values, okay, are our inputs in domain, and our range is of a function is the set of all the possible output values, and so that is our y values. Okay, so just some good things there. All right, get that into focus a little bit more. Sorry about that. So, all right, we're going to get in and start these first 7 problems. Okay, so if you are ahead of the game and are like, I got this, I know how to do this, then you can just fast forward to check your answers. That's totally acceptable. Okay, so we're looking here in exercise 1 and 2. Okay, determine whether the relationship or relation, sorry, is a function, and then explain. So what we're looking at here, we got our inputs. We have an input of -2, an output of 4, an input of 0, and an output of 5, an input of 1, and an output of 4, and then an input of -2 and 5. So what we notice is we have 2 of the same inputs, and we need to determine that do we end up having different outputs, and we do. So not a function, for number 1. And we say because one input had 2 outputs. Okay, so we know we can't have the same if we put in the same input, we should always get the same output with a function. If we end up getting 2 different ones, we know it's not a function. So let's look here. So remember, we have a relation, and we're looking at our coordinate pairs, right? It's input then output, input, output. So we have an input of 0, output of 3, an input of 1, output of 1, input of 2, output of 1, input of 3, output of 0. So we do not have any repeating inputs, so this is a function. And then we can say because no repeating inputs. Okay, no repeating inputs. Looking at 3 and 4. It says in exercises 3 and 4, determine whether the graph represents a function. Explain. So we can do this rather simply. And so an edge is so vertical lines up and down, right? Uh, Going back to basketball, right? Vertical is how high you can jump. So it's up and down. So if you need to use a piece of paper or a note card as a straight edge, we're just looking on there. Is at any point, oh, right there, that is a point where if we drew a vertical line, it'd go through 2 points. Does not pass the vertical line test. So we can say not a function. And does not pass or fails. And vertical, I'm going to abbreviate vert line test. And we can do the same thing on number 4. We can just go right across there, and we notice that it's always just going to pass through once. Okay, so this is a function. And this because the reasoning is equally important as knowing that it's a function, right? Being able to explain your reasoning. So this is a function because passes vertical line test. Okay. So again, the reasoning is equally important as we're going through on that one. So we're just practicing our understanding and how we would explain these. In exercises 5 and 6, find the domain and range of the function represented by the graph. Well, okay, so domain. Domain is our possible inputs and range is our possible outputs. So we're looking at all of the possible values for our domain. So we have values from 0, 1, 2, 3, 4, and 5 for our inputs. So our domain, okay, is a set of numbers. X is going to be between 0, so it's greater, so 0 is less than X, or less than or equal to, and it's less than or equal to 5. So we write it as a compound inequality. Okay, so X is sandwiched between 0 and 5. And our range, and you could even just say it's 0, 1, 2, and list it out in that way, but we can also write it this way. So our range, we notice that there's 3s and 4s for our range. So our outputs are either 3 or 4. So our Y is either 3 or 4, between 3 and 4, and including 3 and 4, I should say. But so that's what we see there. So can write it in that way. Now for number 6. So our possible inputs. So that's our X values. So we notice it's from -3 all the way to +3. So you don't even have to write all a domain all the way every time. You can just put a big D there and say that it's going to be from -3 and it includes -3 all the way up to +3. Move the camera just a little bit. Okay, and then our range, you just can put a big R there. It is, so our possible Y values, so it includes 0 all the way up to +3. So from 0 to 3. So that we're just using those inequalities that we looked at last unit and writing our domain and range. We got one last problem here. This is problem number 7, a nice little word problem for us. So if you want to pause the video, try it on your own, come back, that's fine. Otherwise, we're going to go ahead and go through it. So we have the function y is equal to 12x, represents the number y of pages of text a computer printer can print in x minutes. Okay, so we want to identify the independent variable and the dependent variables. So the function y equals 12x, the number of y pages of a text a computer printer can print in X minutes. So given a certain number of minutes, it will print so many pages. So we are, X is going to be, is independent. It's the one that we're going to, independent. Okay, I guess it's right there. And our Y is dependent. So it depends on the number of minutes we are going to run the printer, how many pages we get printed. So the domain is 1, 2, 3, and 4. What is the range? So here we need to create a table. All right, so if we have so to be able to work through this, we have our inputs, the number of minutes, and our outputs, the number of pages. Okay, and they gave us, we have 1, 2, 3, oh, that one's a little bit small, and 4. Okay, so we're going to plug that back into our function here. All right, so substitute in 1 for our x. 12 times 1 is 12. And then 2 times 12 is 24. 3 times 12 is 36. And 4 times 12 is 48. So that is our domain, our range. So our y outputs. Oops, sorry, I was doing all that and you couldn't even see it. Okay, 12, 24, 36, and 48. So we're just making a table there. And our range is from 12. Our y is a set of numbers. And so I'm going to show you another way to write this when we have our discrete points. So discrete points are when we have just individual points. We don't actually have a line or a curve connecting every point. Or we have just individual points, so like points in a table. So we can actually say it's a set of y's, okay? So it's going to be 12, 24, 36, and 48. And that is, so we can put it that way, or you could say just do the 12 is less than or equal to y, which is less than or equal to 48, if you are more comfortable with that. So that is all. Make sure you complete this in your workbook and have a great Monday or Thursday and Friday.